Ladies and gentlemen, welcome back to another live stream. So I guess this is part 4 of this series. You can find the playlist on my channel. Anyways, you can join also my Discord server down below. I'm gonna notify everybody. And there we go. Okay, so we're gonna start in a few minutes. So if anybody's interested to join in, they can catch up. Hello, Theobears. Wrong account. So this is what we got actually from in the previous or the last stream. Oh yeah. Let's go. I'm not sure honestly what we're gonna work on today. I mean, we could work on lighting, we could work on what is it called, skybox, we could work on what else, we could work on architecture maybe, and oh yeah, we could also work on the controller, like, you know, controlling the camera. What do you guys think? Should we work on, or at least try to work on the skybox, the camera controller, or architecture? Or what do you guys think? So we can start in a few minutes. Hello to Zugiti, welcome to the live stream. Yeah. Welcome, welcome. Did you come from the Zig Discord server by any chance? Or just YouTube recommendation? Ah, I see. I see, I see. If you guys have any questions before we start, we're gonna be starting in a few minutes. What is the stream about in general? Is it about developing a game? To be honest with you, we're currently just, you know, trying Vulkan with Zig pretty much, so I don't really have a solid end goal unless if you guys suggest some idea. then yeah, but mostly I'm just gonna be covering like the actual API. But yeah, I'm gonna be using the API to try to do stuff, and we're assisting with AI, and that's it, pretty much. We're actually using the latest Vulkan, like Vulkan 1.4. Yeah, exactly. Kind of like a soldering string, but less intense. Yeah. Yeah, I love soldering streams. Especially his like past ones. Although honestly, the ones that are like the latest ones, I don't really like them that much. But the past ones, oh my god. Like he was building like custom, I guess, language, all sorts of cool things. But yeah. All right. So how much time have passed already? Yeah, 6 minutes. I'm just gonna finish my coffee and we can start. Okay, I guess that starts already. Just finished up my black coffee. All right, let's go. So this is what we got in the previous stream. We just got a mesh that is currently being drawn into the screen. So as I said, what do you guys think? Should we go with the, oh my god. Let's pop out the chat. And let's go to the code. Should we start with the controller, camera controller, or should we try Skybox? Or what do you guys think should we do next? Okay, let's see what we got. By the way, I actually did a little refactor of camera, which is this guy right here. Don't have a ticket or some list. You could just put it in the chat pretty much. Yeah. I wonder if we can like make some poll or something. Is there a way to make a poll here? Oh, there is. What should we work on next? Let's see, architecture. There is camera controller. And what else? Skybox. Honestly, I've never implemented Skybox in Vulkan, but I guess we'll assist with the AI if that got selected. What's next? Camera controller using SDL3. And there we go. Oh, I already have camera controller. Oh man, just ignore the last one, I guess. Oh, it doesn't actually show. Interesting. So, okay, so I'm supposed to end the poll at some point, and then I could see the results, I guess. Yeah. All right. Anyways, so while the poll is going, what we're gonna do, I'm gonna show you what I've done in the refactor off camera. So even before that, I actually tuned the MVP. Here I changed the MVP so it's actually rotates like that, as you've seen there. So what we've done here, I haven't honestly looked into it too much, but we moved the camera much closer. Yep, moved from 3.3 to 1.8 for a closer look. Look slightly up from the floor. Model fixing orientation. Yeah, because like the original model was rotated, so we just kind of like had to add like minus 90 degrees. So apply a 90-degree fix on the X to stand it up, and we increase the rotation speed to 30 for a more lively view. Okay, what's next? And we got a spin matrix, so matrix 4 from rotation angle on like around the up axis, right? The up vector, and combine spin it while it's standing up, right? So spin dot multiply fixed rotation. So, and here we got the same thing, I believe, right? So projection dot multiply view by multiply model. Okay, so that's the tuning of the MVP. Next up, we got the holy refactor, because oh my god, that was insane. Obviously, I did like assist with AI for this, because that was huge. But it's pretty much the same code, just a little bit more structured. So I kind of like split it up the code into both app and core, where core basically have all the Vulkan static stuff, like, you know, the swap chain handling, what else, the window, what else again, let's see, actually the allocator, the window, the graphics context, the swap chain, the depth texture, the command pool, the command buffer. So basically the things that wouldn't change much, right? So to just remove them from our view, I just kind of like encapsulated them into core.zig. And I may actually extend this core.zig more in the future. But right now, as you can see, just handling that gnarly swap chain stuff and so on. So, and you just say begin frame and end frame and recreate swap chain, etc. So it's the same exact code, just kind of like structured into functions, into its own structure. One problem that I found by trying to abstract into core, even with AI, is the fact that I was getting some, what is it called? Sigfold. Yeah, I was getting some sigfold in terms of the dispatch table that is inside of graphics context, because like the binding basically loads all the function pointers from Vulkan and it stores them in a dispatch. And when we actually do it this way, where the graphics context is getting moved into a new struct like core, what happens is that those pointers gets invalidated. So to fix that, what I've done is heap allocated GC, so pointers to it remains valid after core is moved / returned. So we allocate. So once we this is also useful for multi-threading, for example. So yeah, you just allocate the graphics context on the heap, and that would make sure that the graphics context never moves. Because when you move it, you're moving like the pointer itself doesn't change, right? So yeah. And error defer allocator.destroy. So that's the only, you know, major thing that you have to watch out for when you're doing such a, and I wouldn't be surprised if such a thing was biting me when I was actually trying to make such an application before, and that's when I actually gave up, because oh my god. Like, it's a very subtle bug. Luckily I was actually like trying to mess with multi-threading before, so I kind of had to go through like some few hours of dealing with such a bug. So I kind of realized exactly what's going on and fixed it immediately. So yeah, that's pretty much it. Nothing fancy here. Next up, we got the app.zig. So app.zig. So honestly, let me just show you app.zig itself directly, I guess. So where's app.zig? There you go. So now app.zig, what it becomes is that it becomes just the core and then just the application specific resources, right? So it just becomes the mesh, the texture, the sampler, the uniform buffer, the scripture set layout, the pipeline layout, and the pipeline. And maybe we could even like put in the sampler somehow in the texture, possibly, if we want to simplify this, although that kind of suck performance wise, but well, anyways. And here we got the start text and should quit. So here we just initialize the core, which basically set up the graphics context, the SDL window, etc. You just give it the title, the width, and the height, and then you go straight ahead and create a mesh from an OBJ, and you create a mesh texture. So as you can see right here, right now, I don't have that swap chain code that I had earlier, which was really like messing up with my brain here. So I just have the stuff that I really care about right now, which is the mesh texture, the uniform buffer, the sampler, and yeah, it's like the AI kept messing with the kept like removing or omitting the fields that doesn't have defaults. So I just snapped and told it to keep all the defaults because I was like fixing it every single time and it was getting very annoying. And then here it just said all fields preserved. Anyways, pipeline setup. Here we got the uniform buffer and the combined image sampler. Cool. Here we're getting the scripture set layout, the pipeline layout, the pipeline, and we're good. Next up, we got the run function. Right now it's way smaller. So it just have like the event handling. And it have the command buffer. And we just like call core.begin frame and it gives us back the command buffer. And otherwise, if it's minimized, if the window is minimized, we wait for the next SDL event. So yeah, we sleep until we get an event essentially. Here we just calculate some time, some initial MVP using the time and the swap chain extent obviously. And here we just write to the uniform buffer using that MVP. Okay, and then we just draw. So we just record the command buffer and we end the frame. Cool. So the record command buffer, now just have like begin command buffer, transition layouts, command pipeline barrier stuff. And yeah, that's basically it. Nothing fancy. And we just have right now this setup image barrier. So instead of having to create an image memory barrier and fill up this whole, you know, tax form, we just have one function that takes in the image, the old image layout, the new image layout, and the aspect, and then it just does its job. Though currently it's not as performance and granular as it should be, because here I'm just doing all commands. But optimally what you would do is you would tell it exactly what stage you're targeting here for max perf. But for now we could keep it this way since it's way simpler to kind of like, you know, experiment while creating our engine pretty much. And here create pipeline without like having to worry about synchronization every single time. Next up, just to create pipeline. I didn't change this so far, and yeah, honestly the pipeline is getting kind of noisy. I may actually make a structure for it too, but yeah. So yeah, that was it guys for this refactor that I've done off camera. Is there anything else I missed? Yeah, and the texture transition layout, yeah. And I also added to texture.zig, I'm tracking the layout, the current layout. And though this have a little thing that you gotta worry, like that you gotta keep in mind about tracking the layout like this, is that if we ever do this in multiple threads, this wouldn't work. This image layout tracking wouldn't work, right? I'm only doing this because I'm pretty sure I'm only gonna be recording the image in one thread. Though maybe we could like make, let's say, a thread local and use it to track layouts. But to be honest with you, optimally at some point we just gotta make a render, what is it called? A render graph, which basically handles all the transitions for you, etc. but yeah, for now we're just having like a raw kind of setup, but yeah. And here we just got a transition layout. You give it the device proxy. That's interesting. I didn't notice that. I guess we'll see about that. Anyways, so we got the command buffer and the new layout. Now here we just see if the image format is a depth format, then we just use the depth aspect mask. Otherwise we use the color aspect mask. And here we just create an image barrier, image memory barrier of the self.layout, the current layout and the new layout and so on. And again, here this is kind of like a sledgehammer. We're just doing all like raw synchronization, not like, it can be more granular, that's the word, right? And so it would perform better, like more performance, but right now we don't really need that much performance, because otherwise we'd have to also add here the src access mask and so on, and we'd have to bother with that every single time, which we don't want to do right now. And finally we just track the new layout, and yeah, and we call the pipeline barrier pretty much. Right. And other than that, did I change anything here? Ooh, okay, what is that? BP. Let's see. Copy from buffer. Self.transition layout. Yeah, and we're using that function basically here. So instead of having that whole image memory barrier, we're just doing that. Anything else? Yeah, that's great. And here finally the depth format. We just look up the formats. If it's kind of like a depth format, then we just say true. Otherwise we say false. And yeah, this is basically it. All right, so let's actually end the poll and see what's up. Okay, so only one vote, which is the camera controller. So let's go, I guess, fine. Let's try to make a camera controller. And I actually found like a tip. Let me show you. If you go to Gemini, I'm not sure if you like need, whoops, not this one. I'm not sure if you need like a paid account for this. But I found it quite interesting. Oh, oh my god, I forgot to upgrade, damn. Well, that's gonna be interesting. I forgot to upgrade. Damn it. So I guess, yeah. Here's your answer. Apparently it doesn't. It doesn't. So basically there was an option here where you could like add an actual repo and it would just work. But anyways, whichever. So what we're gonna do then, we're just gonna grab this app and see what we could do. So pretty much just this kind of like part, we need to make it into a camera. So camera.zig, and now let's see. So it's gonna contain, I mean, honestly, let's see what the AI would actually do. So can you extract the camera .zig out of here, out of this? Now let's see what it's gonna do. I'm not sure if the free model is as good, but anyways. Extraction dedicated from your main application is a great way to clean up your make MVP. Okay. I target up FOV near far, and then you basically create the scripture matrix out of those properties. Yep, that seems great. Can you add SDL 3 input inside the while loop and run? We need to update camera.zig to handle movement, vectors, and rotation. Oh boy, what it's trying to do here. That's strange. Handle the mouse. In your main, you need to track delta time. Alright, let's grab this camera first. Fine, camera.zig. So this works so far. Though, should we grab the input here of SDL? I mean, fine. So pubfn on event self camera. Though I'm not sure why it's just passing in the camera like this. I mean, it's kind of fine here since it's just constant, yeah. But in this case we need it mutable. Right, and in fact we could say const self is equal to this. No, they didn't get rid of it. I just happened to have like expired the Gemini plan. Let me see if I could like actually pay it right now. Yeah, I didn't pay attention that it like got expired today. That kind of suck. Yeah, I can't right now, apparently. Anyways, fine, whatever. We don't really need it that much anyway. So let's go with self. Self here, and void. Yep, pretty much. And what we're gonna do? We're gonna grab an SDL event. So event c.sdl event. Now we're gonna need SDL here. So const c is equal to import SDL. Well, c.zig, my bad. There you go. And I guess .c, right? Yeah. Cool. And yeah, that seems to work. So now we're gonna switch on the event, right? And if we basically got like well, we're gonna switch on the event type. Using AI doesn't have diminished returns if the project become bigger and bigger. What do you mean exactly? In what kind of aspect? Like if you watched my previous streams, you're gonna see what kind of things I struggled with using the AI for, and what things it really kind of like boosted our productivity. But yeah. So I kind of like started, the thing is I actually have made such a Vulkan project for a lot of times and just gave up on it before I could even see a triangle. Well, actually I did get into a triangle, and one day I even got into a texture and even a mesh, really. But yeah, so up until here, so like up to the previous stream, I didn't really pass that, so I just gave up at that point. So right now we're actually seeing more stuff because I still have more energy because I was trying to use the AI to go fast. You know, I also kind of like depended on, what is it called? Yeah, on the, like if you see the binding repo, you're gonna find the graphics context.zig. So we just copied that, and we're also it starts forgetting about variable names and stuff like that. Yes, it definitely did. Like a lot of times it did do that. So like for example, it would omit fields, or instead of like .false here, so which is like an enum here, it would say vk.false, it would just say false. But yeah, there was a lot of trouble getting it to work. So like you just had to go through a lot of iterations. A lot of times it would omit some elements because it just seems like it have a default values, but in reality it doesn't. And what else did I have a problem with when using the AI? But yeah, definitely you don't want like to try to refactor the whole thing, and definitely not without GitHub. Like you should always try to commit your changes, try something, and then if anything happens wrong, you know, you just like revert to another version. But yeah, other than that, that should be good to go. Alright, so let's see what we got here. Switch event.type. Okay, why am I not getting autocomplete here? And why don't you use GitHub Copilot? I really hate it because I find myself every single time that I'm coding manually that I'm like trying to wait for it to do its thing, and also I need to pay another subscription. Although I could probably like you know, activate my educational license because I'm still in university, but I just was lazy to do that. So I should probably look into that. But to be honest with you, as I said, I actually kind of abandoned it in the past, because the thing is, I'd like to, when I'm in the code, when I'm in the IDE, I like to code myself. If I want the AI, I would just go back to the AI, right? So I don't have that problem where I just lock up and try to wait for the GitHub Copilot to do its thing. But yeah, that's why I kind of abandoned. But we could actually try it right now, really. I actually disabled it. So, but I don't really like the free plan. I don't think it have much, but we'll see. Okay, there we go. Okay, let's try GitHub Copilot. I haven't like tried it for a long time now, and this is just like the free plan, so it's not gonna really last that long. Though I like, out of the stream, I would look honestly into activating my educational license, because like I have to redo that every single year. It kind of sucks, and you have to give them some documents and stuff. But yeah, anyways, whatever. So we got the key here, and we got the delta. Now if key is equal to CSDLW, now here this kind of, I mean, it would probably work, but it's not the best way to do this. Use a vector. Let's see. Bruh, come on. Const input, and it's gonna be like a vec3, right? Okay, that's interesting. So if we do it this way, then we get this. Yeah, that's not bad. That's, I had something else in mind, but that's also nice. So yeah, go on. All right, so I guess that's it. I mean, we could test it out. But anyway, so right now we actually gotta use this camera right here. So let's go back to our app, and instead of having where we're doing the uniform stuff here, uniform buffer, and where's that thing? Oh, I'm not writing to it here apparently. Okay, so where is it? Make MVP, there we go. So instead of make MVP, we're gonna have a camera. So camera. And obviously we gotta say const camera is equal to import camera.zig. Let's go. Alright, so we got that out of the way. Cool. Now let's actually create it. Dot camera is equal to camera.init. Okay, so here the AI, the GitHub Copilot helping me. Great. So init And what we're gonna do next, let's go back to here. So here where we're making the MVP. So instead of this, we're gonna just get it from the camera. So get the scripture matrix, and here it basically takes all those properties and it kind of like calculates one MVP from it. So kind of like bake those properties into one matrix, right? And then we write them to the uniform buffer too simply. And we don't need this anymore. And in fact, we don't need the time either right now. But let's just comment this out for now. Fine. And yeah, I think that's it. Isn't that the case? So we don't need this make MVP, I guess, anymore. Right? So let's try this out. And let's see. Okay, so wait. I haven't actually called the input function of the camera. So let's go where we're dealing with the SDL input events. Where is it? Like SDL pull event. There we go. So here, instead of doing this, we could just switch. Or actually, instead of switch, no. We want to say self.camera.onEvent event. There we go. And now what's going on? Oh, we're using the wrong event because it got changed in SDL3. So let's go ahead and fix that. So enable to translate SDL key down, renamed SDL event key down. Yep. So SDL event key down. So as you can see, for example, also when working with newer versions of stuff and like new languages, it also kind of suck in this manner. But yeah. So why this doesn't work now? SDL event. Oh yeah, key down like this. So one skill that you must have for sure is debugging, because like when things go down, you have to figure out what the heck is going on. Otherwise, you're done. Prong only allowed. Yeah, else. What it did that again here? Okay. No field named. Yep. So event.key. Right. Now let's try again. Rename to SDLKW. Okay. So right now they're called this way. So this is just like the SDL3 changes. So the AI doesn't really know about them yet. So debugged run. And let's see. No field named X instruct. Oh boy. I see. So it's gotta use vic3.new. There you go. And now I'm just gonna remove all of these and hopefully would understand what the heck I'm talking about. There we go. What? I mean, it works, as you can see. But obviously, first of all, it's in the global coordinates, but it should be in the local coordinates, meaning like it takes into account the direction of the camera. And second, it's, you know, not smooth, pretty much. So let's tell it to try to do that, hopefully. Let's see. So also another thing, as you see with the AI, is that you need to know like technical words. We need to implement rotations now. Yeah, so basically what we're doing here is that the camera movement is in global space, meaning it doesn't take into account the direction of the camera. So it doesn't, yeah, so it doesn't move in that direction. So right now we just got to do that. Let's see. So take into account the camera's current orientation, and let's just see what it's going to do, if it's going to figure it out or not, because it definitely doesn't know about Z algebra. Nah. I think we're going to be using like Gemini for this. for this task, right? So what are you studying for? Computer science, pretty much. Computer science. Okay. I actually paused for a while before, and then I got back into it. But yeah. So what we wanted, so what I'm gonna do here, I'm gonna try to copy this code to Gemini, and then I'm also gonna give it a Z algebra. Where can we find the Z algebra code? Let's go to here and just give it this code, and let's go. Implement camera movement in local space instead of global space to take into account orientation. Count the orientation. I find Gemini a bit faster than ChatGPT. I've never really like tried in depth. What is the other model called? Claude. Yeah, I've never really tried the in depth. It's a little bit more expensive than the Go version, because like right now Google and ChatGPT have the Go version, which is a little bit less expensive, but yeah. To implement camera movement in local space, you need to calculate the camera's relative direction vectors. Forward vector norm target minus I. Okay, so let's try this. I mean, right here, so as you've seen, I gave it Z algebra code, so we could figure it out, because they have no clue about Z algebra. So pub on event, and there we go. So wait, what? That doesn't work. Yeah, there's no cross function there. What? No way. So why it told me that, like, why it doesn't, the LSP kind of suck here for some reason. It doesn't give me the cross, as you can see. I can't click it. I'm not sure why. And it also doesn't know about this ones too. Yeah, so anything that uses this right thing, yeah, I'm not sure why. Why the cross function is causing problems with the LSP of Zig. Yeah, it's using some calm time stuff. Well, I see. I tried using AI very few times. It works, sorry, but still need at least 5 years of development to where that happens. It will really explode. I mean, yeah, it's definitely not perfect. You gotta know what you're doing. Like, the thing is, AI is pretty good if you if you've been coding like for 8 years already, right? So you kind of know what you're doing. I just don't want to waste time and memorizing and stuff. But yeah. But like, for example, if you didn't know anything about Vulkan and SDL, and just like, especially if you don't know anything about programming, you try like make a whole. Also, you gotta worry about the structure, and you also gotta need to be able to kind of describe your problem to the AI, because it doesn't know what you want either. So like here, for example, you would tell it, I want it to use local space instead of global space, but yeah. But if you guys have some more like AI kind of like experiments that you've done, or like what do you think about the difference between them, then let me know. It sees a constant point into a field in the switch, doesn't. I mean, to start even considering the interaction between other files and things like that. I mean, you can use something called MCP. I just honestly haven't really tried to go deep into the AI rabbit hole, because interesting. Yes, YouTube. This is exactly what I want to watch. in 4:20 to sleep. I mean, I'm not sleeping either, so it's like 2:20 a.m. for me here. So we're all procrastinating. Santa Orels, welcome to live stream. 23 at night here. But yeah, so as I said, there is MCP for that problem, but as I said, I just haven't really dug too deep into the AI rabbit hole. First of all, it's quite it gets expensive very quickly if you do something crazy, and second, I just haven't done. I mean, like the current tools kind of work fine for me, not perfect, but like for example, if you told me to like let's say use something like what is it called? You know, that version of VS Code that have an AI embedded into it. I start forgetting names. Yeah, I forgot that application, but there was like an application which basically, yeah, Cursor, exactly, Cursor. Yeah, so like I don't really like such tools. I feel like I'm losing control, though maybe I just kind of ignorant. Maybe I should just try it more and see. But I just haven't really found them comfortable. I want to just have the AI by itself, but yeah. So MCP could help you like, you know, having the AI interact with your files, see all of your files, you know, could execute commands and so on. But again, I just haven't dug deep into it, but yeah. But if you guys have any experiences and like you can convince me on something, then sure, I'm open for that, pretty much. But yeah, static wrapper recommended for library authors. I mean, maybe we could make some stream just like messing with the AI stuff. But yeah, if you're modifying Z algebra, the most LSP stable way to write this is to pull the function. Can you make a function? A helper function that would fix the LSP. Yeah, exactly. So let's just grab this. So we could have like some good autocomplete stuff. IDK, the MCP is kind of a strange thing. Do not understand exactly what it is when we have things like Claude Code or Gemini CLI. They've outcoded it feels like, and codecs from OpenAI. Honestly, one thing that it kind of like made me stay away from those tools is just too much choices, first of all. It's like you have Claude, like CLI, OpenAI codecs, and like agents, and oh my god, like, and everybody's like jumping on the train. Like on the hype train, so you never sure it's like what things is just hype and what things are solid, and what's the difference between all of them, and like all of them wants a beefy subscription from you, and you become dependent on it too. So if you can't pay, you're you're in a very terrible luck. But yeah, I mean, we are doing graphics programming wherever, even I mean, we're doing even worse. We're doing Vulkan, so we're probably the most, what is it called? The most qualified to use AI. But yeah, watched Eisenfrog video. Who's Eisenfrog? Maybe I have watched it, but I didn't like recognize the name pretty much. But yeah. Alright, so let's use this cross-vec thing now. So forward self.up. Not gonna lie, if you get any of them for free, then it's worth to try Codex, Claude Code, Gemini. Like, what's the difference between them? And what's the difference between them and MCP? In fact, we could ask ChatGPT right now. I find ChatGPT more good at presenting stuff and like comparing stuff and kind of like decision making in general. So that's something that I've kind of like noticed. But yeah. What's the difference between MCP and stuff like Codex, Claude Code, and Gemini CLI. I just searched in the web, bruh. These things, think of it like this: plumbing. I think maybe they're using MCP themselves, maybe? Yeah, probably. MCP is not a coding assistant, it's a standard that lets AI. Yeah, I know about this part, this fact. So they're probably using it to implement this stuff. Don't forget to say thank you, they will forget. And MCP is more for tool calling, I guess. Did not dig into it because I did not find tools that used it where I was interested. Yeah, I think MCP is kind of like just a protocol like HTTP and stuff. So basically, instead of every model having to implement like tool calling and files and all that stuff itself, and like especially if you want to make like, let's say, cross-platform IDE like Cursor, which uses like multiple models and so on, what you gotta do is like you have to implement a separate implementation for each model and what is it called, an external tool, right, for AI. So it's kind of like combinatorial, but here you got MCP is kind of like the protocol that all the models uses, I think. Yeah. Chaotic state of graphics program. Oh man. These are apps you run, usually in terminal. They act as AI pair program, generate, edit, debug code, run commands, analyze repos. Strong reasoning plus code accuracy. Can use MCP to connect to tools. Strong reasoning plus code focus. Yeah, as you can see, it uses MCP itself pretty much. Can use MCP to connect to tools focused on automation plus coding workflows. Gemini CLI, very strong multi-model plus large context. I wonder if like the educational kind of license have these tools or not. But yeah, because like there is something like GitHub education, I think, pack. This is the thing that I was using before. It gives you like JetBrains tools for free if you're a student. And some other stuff like Intro to Copilot. Yeah, it does give you Copilot too. Intro to open source. There's AI prompting, technical writing, huh? Would be interested in seeing MCP server for a Ghidorah compiler. That would be interesting. There's probably some tools already for that, maybe. Why don't try learning the subjects? I mean, doing everything by hand. Doing everything by hand is just too much wasted time. Especially when you're working with such a like huge domain. There's just a lot to learn. But yeah, mobile app development. Explore GitHub, profile readme, Launchpad. It just gets repetitive too fast. I probably have made that Vulkan triangle manually for like, I don't know, 70,000 times already, so I just use like AI to go through a lot of the code. But yeah, Final LLM a great way to bridge knowledge where you lack, especially on the start. Yep, definitely. Remember when you were in middle school and learned about multiplication, multiple digit, never as every kid said, why we're learning this if we can use calculators, and now that you are older. Yeah, kind of exactly. So like it's kind of like you have a calculator. I mean, yeah, you gotta know how to multiply and stuff, but at some point it doesn't really add up anything if you do it manually, so you just use the AI to save time. But yeah, how to use resources and offers. Anyways, let's go back into business. I think, yeah, let's go back into business already. Let's not waste more time on this. So you know how the LLMs use vectors for tokenization. So LLM can basically easily point you in the direction which you don't know even existed. Use vectors for... Yeah, I really love it for exploration, that's for sure. There's also some concept that I found very interesting was, what is it called? I think vector database. Yeah, vector embeddings, kind of. This is a very interesting thing where like you could store multiple stuff, like multiple files and so on, into one kind of like matrix of numbers. It's kind of like used for compression, and like, for example, you could store a lot of faces into it, like let's say a lot of faces of people, and then quickly search the faces without actually storing like all the images, you know. So you just, it's used for RAG, providing context to large language models. Also semantic search. Yep, there you go. Semantic search. So like instead of searching like this, well, I mean, Google is not really, no. Google is using PageRank and other crap, but yeah. Anyways, so anyway, whatever. Let's go back into the code. All right, so what we have got so far. Yeah, I wanted to, as I said, I wanted to use this crossvec now. So let's just comment this out. Let's say const right is equal to crossvec. Yep. And the same thing here. So I just use this function instead to avoid that LSP problem where it doesn't know what's the type and so on, which suck. So yeah. And now we could remove this, and there we go. And I think we're good now. Yeah, sick. Why are you using the fast Gemini model? Did the thinking model limit run out? The thinking model, even though when I had it, like right now my subscription just expired, I didn't really notice until now, until I started streaming. But even when I had it, I wasn't really using it because I found out that it's, most of the time it just kind of sucks. It's kind of like when you overthink, you know. You don't always come up with a great solution. Sometimes if you don't overthink, you actually come up with a better solution and in a faster time. And that's how I see the thinking model. It's like after trying it several times, I was thinking that maybe it was better, but mostly I didn't really see an improvement. Most of the time it was just kind of getting worse. But yeah. So yeah. Anyways, then don't try Gemini 3 1.0. That model really likes to overthink. Yeah. So I'm not sure why it's like going step by. Oh yeah, well the delta. We need the delta. We need the delta time. That's why it was going that way. So delta. But wait a second. If we do the delta, no. My bad. So you know what we gotta actually do? Yeah. Let's try using the AI for this, fine. Can you refactor this into making the on event only mutate the state of input, then have a process event function that takes in a delta time and apply that state every frame. Bro, what? Alright, let's see. So as you can see here, we got only the events, like the input gathering. Then we're gonna have an update function which gets called like every single frame, and it does this stuff. So let's try it. Because right now, just to show you like what I'm talking about, is that the fact that like right now the kind of like the input is jumbled up with this kind of like movement code, so I can't really call it every frame and so on, which suck, because like you just move one big chunk every time you have the key down, basically, instead of having smoothly go forward. So right now, let's just copy this code and let's put it here and see. So on event, so we're good right now, right? Now we just gotta call the update, I think. So no field named input instruct camera. Yep, let's actually add those fields. So where's the input? Ah, there we go. I'm not sure why I did it this way though. No, not this way. My God. Can you make input field a vector 3 instead? As you can see, it doesn't always come up with the best, way of doing things either. So like here, instead of having like just a vector 3 for the input direction, it made this insane structure right here, like forward boolean, backward boolean. bruh. Anyways, let's just, just generate the whole file, please. Let's go. Let's go. Sig build run. LLM and best solution never said he could do that. Yeah, it definitely doesn't. So yeah. All right, so right now we get a call. So we're already calling on event every time we got an event. Right now we got to call updates every frame, and we got to figure out how we can get the delta time. So how are we gonna get the delta time? Now we could already get the time. So what we're gonna do with this? So we already got the start ticks. So we could grab the dt. Yep, const dt is equal to, time minus start ticks, blah blah blah. And then we could just say self.camera.update before we write it, I guess. Yeah, before we get the descriptor matrix, I think. So self.camera.update dt, and let's go. Now it should be way better. Oh, what the heck? That's too fast. Huh. Yeah, it's too fast for some reason. I'm not sure where it effed up again. Anyways, let's see what we got. dt. Wait, self.moves. Okay, so the move speed is 5. Or maybe the delta time is wrong. Wait, let me make sure that the delta time is right. So we're gonna print dt, or yeah, do that please, thank you. And let's see. Yeah, what the heck, bro? Delta? Why? That's strange. Hey, I love your content. I will try to switch from the web GPU to Vulkan. The Z game dev is maintained for some time now. Hello, dev4GPU. Welcome to the live stream. Web GPU. So honestly, I keep on thinking about the difference between Vulkan, Web GPU, SDL3 GPU, and a lot of times, when you're in the trenches with Vulkan, you really think, oh my god, this would have been way easier, But then I kind of see also the limitations of them. So like, for example, I want to at some point, hopefully, to try out something like Vulkan Video. That's one thing. Why would Vulkan be good? Now, if you just want to make a game engine like a regular one, you're probably better off using Web GPU. Although, even though that, it sucks in its own way. There's also NVRHI. But the real killer feature of using Vulkan directly is that first of all you have like top tier debugging. So like when you run what is it called, vkdev, what is that called, vkconfig gy, right? When you run this and you say API dump, you're gonna see the raw Vulkan API calls, right? And you know exactly what you're doing, you have full control. But if you were just using WGPU, you have to like see just the Vulkan API calls that the web GPU itself is making, and you got to figure out what the heck the abstraction is doing behind your back. That's one thing. The other thing, as I said, is like modern extensions. For example, you can't implement bindless, which is going to make our job way easier when it comes to binding resources like, you know, images, textures, samplers, whatever, and buffers. Even you could even like use you know, the device pointer directly. Also, you don't have to worry about like cross platform, like cross API stuff, because the thing is about these cross APIs like WGPU or web GPU and what is it called, an SDL3 GPU, is the problem that they have to account for all platforms, so they remove any feature that doesn't support all platforms. So you're kind of like stuck in the lowest common denominator, right? So for example, you can't do ray tracing. So in VRHI you can actually do a ray tracing somehow, but again, probably not the best way to do it. But anyways, yeah, my goal to create my own custom engine with zero dependencies and to be cross-platform. Zero. There's no need to do like absolutely zero. I mean, if there was like some Vulkan libraries out there in Zig that would have helped us, you know, cut down on the code that we have, but doesn't like, you know, hijack all the control we have, I would have definitely used it. But unfortunately there isn't. It's pretty hard to make an abstraction over Vulkan. But yeah, I want to be vendor locked by myself, not by other maintained Zig dependencies. Yeah, but like some dependencies are just like necessary, you know, like for example the Zig binding, and what else, an SDL3 binding. But yeah, whatever. Anyways, I'm not sure what I was even talking about. Yeah, another feature that I like about using raw Vulkan, as I said, is I want to try Vulkan videos so bad at some point. I just haven't got into it because it's probably too complicated, too complex. That's one thing. The other thing is that if you use, let's say, something like FFmpeg video, Vulkan, FFmpeg Vulkan, you also gonna need like raw Vulkan. Now those other APIs does give you like a way to kind of like, you know, get the Vulkan device and do some other stuff, but it's probably a lot of friction. But yeah, isn't the Zig Vulkan binding generated? Yes, it is generated. It generates from the vk.xml. So they basically take in this vk.xml here and they convert it into, you know, the structs at build time. So yeah. Because, oh my god, this is huge. You can't do this like manually in Zig. It's insane. But yeah, what else did I want to say? Yeah, that's pretty much it. So that's my opinion on that. Yeah. Alright, where we were. I have no clue where we were right now. API dump validation. Oh yeah, we had this bug. Yeah, the delta time isn't being calculated properly. Let's see. So time minus, well, that's obvious why. That's obvious why. For now, we could just set it to, like, we could say self.startTicks is equal to SDL get ticks again. And hopefully now it would work. Oh boy, what the heck? Time 0. No. You totally got this off. Can you fix DT calculation? There we go. And let's just grab that here. And we should be good to go, hopefully now. There we go. That's what I'm talking about. Now we have a smooth camera. Let's go. And it also obviously respects the frame rate, the FPS. Now we gotta implement the FPS kind of like, you know, looking around using the mouse. So let's figure out how to do that, I guess. So on event, what we're gonna do, switch event.key. Okay, let's figure out how we're gonna do this. Or you know what, let's see what the AI would do and just nudge it toward what we think is best. Whoops. Wait a second. Implement, what is it called? You know, mouse rotation. Oh boy, he gives out the picture. It kind of like reminds me of Caspe, like Kerbal Space Program. This game. That was a lot of fun. Although I kind of like find these games boring nowadays. But like it was like mind-blowing to know this game exists when I was younger. But yeah, I had a lot of fun with it. Anyways, so like you got the roll, the yaw, and the pitch. And it's trying to do this here. Can't it use like quaternion? Does GeoGebra have quaternions? These types of games feels like top tier jobless activity. It definitely is. Like I would die to make such a game, but I know for sure I can do that, bruh. There's also like Euro Truck Simulator. Like my god, how the heck does that even? And I'm here like still struggling with getting a triangle on the screen. Like bruh. It's insane. Like anyways, so where I was up to. Oh yeah, I wanted to check if ZAlgebra have what is it called? See, yeah, that's the problems. Like when I try to make a game, like I can't have like the motivation to work on a small game that I'm not interested in. Like the games that I'm interested in, they're just super freaking like complex. Like, you know, Kerbal Space Program, Minecraft. Although honestly, Minecraft, it's kind of doable. Maybe we could try to do it someday using AI, because honestly I have no clue how these voxel stuff work, because it's not just like, you know, drawing multiple cubes on the screen. If you just do that naively, you would just tank, you know, the FPS. It wouldn't work. You have to kind of like construct the whole mesh and like do some grady meshing stuff to kind of like optimize the geometry so it doesn't lag. So yeah, there's just a lot of crap going on there. But maybe we could try to work on it on this project someday. But yeah, but I'm definitely gonna rely on the AI a lot because I have no clue how that works. I just couldn't really find some really good tutorial for that, but yeah. Anyway, so the game for the program is to create the game engine. Yeah, so also another thing is that I don't really find like most games interesting nowadays. I kind of grown up at this point. So like, yeah, when I was younger, I was really interested in into video games and like creating them. It was like crack for me. I could do it like all day long. But nowadays, I really find games very boring. I only find like creating systems that is very interesting, like, you know, using APIs like Vulkan and stuff. Like even when I get into game engine, I feel like it's too like less effort. It just feels too hollow. Like, bro, I have to do this image here and this here and yeah. But yeah, it's its own kind of skill set. Like you need game design, you need animations and stuff. Nah, bro, I just want to focus on the code. I just want to focus on how things works. That's all I really care about. I don't care too much about games anymore, unfortunately. But yeah, so yeah. In fact, I started with Roblox pretty much, and I kept going down the rabbit hole, and we're here today. Not gonna lie, for some time was interested in exploring the graphics programming and all the creating a game, but at some point it seemed not interesting. It does not do anything. Yeah, so like making games at first, it kind of seems interesting because you have no clue how that stuff works. But once you get into some point where you could just like make some like you realize how that stuff works, it just becomes boring because like you just figured out the system, and you also you realize you're still kind of limited and you don't know exactly how the computer really works under the hood. You feel like there's just too much abstraction layers. But at that point you start digging deeper into lower level APIs, but then you get exhausted, like you get burnt out so badly, and then you go back to the abstractions and then you feel hollow and then you go back again. So like you just have this kind of like cycle, this never ending cycle of like going high level, then going back low level, high level, low level, high level, and you just keep on learning some time, like, and you kind of like have a sandwich pretty much, like you just keep on going high low, high low, high low, until you hopefully find the mid level, you know, at some point. But yeah, not gonna lie, for some time, what I hear about mainstream game engines is the bullshit ecosystem you have to learn. Yeah, another thing I really kind of hate about game engines, it's the way they're isolated from the whole programming ecosystem. So like, for example, if you use Godot game engine, like you can't, like you don't have GD script libraries that you could rely on, that the ecosystem could rely on and make. I mean, you have Godot plugins, but it's not like if you had like a raw language, like you could just, for example, let's say C#. Actually, you could use Godot with C#, and that's actually a very solid one, a very solid way of doing it. Like you could have C# in Godot and then use C# libraries. That's something solid. Another one that I liked about Bevy too, it's like you can just use Rust libraries. But things like, for example, Unity, I mean, even Unity, you could use C# libraries. But yeah, it's not as, it's just kind of like in its own bubble, basically. But yeah, at this point, I would not even consider writing an engine if the game doesn't require. Yeah, if you're gonna go make a game, I mean, you could still even make a game engine, but don't try to make it generic. You know, just create whatever things that the game needs. In my case, at least, I'm not really don't have any game in mind. Maybe we could try even Minecraft like at some point, though we're probably gonna vibe code most of the code pretty much and hope it works. But we'll see. I mean, I'm open to ideas pretty much. Here we're just chilling. The problem with engines is that no developer understands. Yeah, pretty much. But yeah. All right, so where we were. Oh yeah, I guess we were trying to like implement. Yeah, I want specific render. I want to render something like Tron graphics where objects are lit by lines defined on the object. I forgot what's the name of that. Outline. Yeah, there is outline shaders. Yes, in Real Engine documentation, so actually is like, whoa, impressive work, smart. Yeah, like if you're gonna be making like, let's say, a production 3D game, then you're probably better off just using Unreal if you're gonna need like, you know, multiplayer and all sorts of things, or Unity. Just go for the mainstream thing, pretty much. But yeah, all right, so let's try to implement what is it called, the we had this oh yeah, so I was trying to look for quaternions. Does this thing have quaternions or not? No multiplayer rabbit hole. Yeah, we could try multiplayer rabbit hole soon too. Anyways, let's see. Where's the algebra again? Vic3, there we go. Okay, so does this have quaternions by any chance? Yeah, I don't think you have quaternions. Yep, so we're just gonna work with, we're not gonna try to be like smart ass about it, so I'm just gonna go with like this, essentially, just vectors. So handling mouse events, we listen for the motion. updating the target vector. Yeah, the cos sign and the sine. Final implementation, set relative mouse mode. So what I'm gonna tell it is to make sure to capture the mouse, but maybe we shouldn't really capture the mouse here. Actually we should, yeah. So capture SDL mouse and release it on right click, I guess. Right? Generate the whole file. Does Tron look really require a whole ground up engine and a combination of custom shaders and some tweaks? What is Tron? Is it something that I'm missing? Tron. Okay, let's just try this out. Whoops. Enable to translate SDL true. Rename true. Okay, try to use SDL true, which was removed in SDL 3. I have the int gold graphics on my user picture on YouTube. What is that? ENG? Anyways, where is this SDL true? So instead of this, we're gonna see true here, and we're gonna see false here. No member named set relative mouse mode. Let's see what we got for SDL here. Set mouse. Yeah, there's set window mouse grab. There's also set relative mouse transform and set window relative mouse mode. I'm not sure which one we're actually going to be using. Let's see the API. So SDL3 API. Okay. It is about the journey, not destination. I want to work for a few months to burn out. Also found an interesting video not so long ago about the Unreal Engine tone mapper. Seems that changing it to AGX changed the looks of the game a lot. AGX, I believe, is like from Blender, maybe. Yeah. Set window, category mouse. There we go. Okay, let's see. So you know what I'm gonna do? I'm just gonna tell the AI this. You have expired knowledge about mouse API of SDL3. This is the new API. Let me know which each one is for. You're absolutely right to point out that it has significantly cleaned up its naming. So show cursor, hide cursor, that's pretty obvious what it does. Cursor visible, returns a boolean indicating the cursor is currently shown. Set cursor and get cursor. Okay, get default cursor, destroy the cursor, create the cursor, color cursor. Interesting. System cursor, animated cursor. So it gets the mouse position relative to the focus window and the state of the buttons. Okay, get relative mouse state. Gets the delta. Okay, since the last time this function is called. This what you use for 3D camera rotation. Okay, so we could actually already get the relative mouse state instead of like maybe calculating on our own, maybe. Get global mouse state. Alright, warp mouse in window. And warp mouse global. Oh, you can get all the mouses or the mice. Has mouse, get mouse name for ID, get the hardware string name, return the window that currently has set window relative mouse mode. This is exactly, I guess, what we need, maybe. By the way, could be a good idea to have a different chat with LLM to use for more of a question documentation, not for coding, to not mix it as only applying the context right now. The context of Gemini is huge, so you shouldn't really worry about that. Another thing I found nice about Gemini is that it's faster than ChatGPT, and it also, like, you could give it a very long input. Though I'm not sure about the free version, if it it's different from the paid one, but yeah. Tell the OS to send all mouse events to your app even if the mouse leaves the window. Tell the OS to send all mouse events to your app. Alright, I'm just gonna tell it to regen, though. Says you should update your to use set window relative mouse mode. Set relative mouse mode. Oh, what the heck? Where's the mode? There we go. While the window has focus. In fact, we could just give it this whole thing. Copy, paste it. Now regen the whole file. Try stop hallucination on my ground. Yeah, that's insane. At least the logic should include a reference to the SDL window. The new set window relative mouse mode requires a pointer to know which window to capture. Alright, let's try this code and see, hopefully, if it's gonna work. All of them, because of how flash attention works, they spread attention to all tokens. It becomes more of a noise than a coherent attention to tokens. We should try to vibe code someday, like an LLM or like a database in Zig or something crazy, something insane. We're probably gonna fail miserably, but you know, we try. Member function expected 2 arguments found 1. Yeah, so it requires the window now. Okay. Where the heck is the window? Yeah, it's in the core. And what the heck happened here? Oh yeah, let's go. It works. Let's go. That's perfect. But the model is, it doesn't have though a role. Yeah, it doesn't have ones for role. So I'm gonna tell it to add that. Why not? Can you add role using Q and A and E? I have no clue what like atrocities it's doing in the math right there, but as long as it works, I guess it works. Do we really have quaternions? What? Nah, I don't think we have quaternions though, so... Bro, what? Wait, what happened there? Oh my god, never... wait. Not that. I meant this one. Oh, there is actually quaternions. What? I'm confused. Oh yeah, because I was actually looking into another file. That's why. Man. So there is actually a quaternion, as you can see. Yeah. So did it like use quaternions for everything now, or what it did exactly? Where's quaternions? No, it's still using... Wouldn't it be better to use quaternions for all rotation? Though at least let's get this and see if it works first of all. So what's up? Quaternion is no member named from axis angle. Okay. So from axis angle. So there is from axis and there's from Euler angles. And we probably won't, probably from axis. And you just give it like an axis and the degrees, but not in radians though. Also, is there a way to set up Vulkan faster? Because spending 2 days trying to render a flat triangle is some sort of torture. Unfortunately not. Yeah, there is no current like abstractions currently. I tried to make some abstractions before for Vulkan boilerplate, but I always like get into this what can I say, like I try to make it generic until I like just give up. Like there's just a lot of decisions you have to make, and like if you just like give out all the what can I say, if you try to make it as generic as possible, you're just gonna like reinvent Vulkan itself. So at some point you're gonna basically make a lot of decisions, like a lot of assumptions, if you want to make it as simple as possible. Like for example, we could assume that there is one window and that you're gonna use SDL3. We don't care. And yeah, and you could maybe make like some boilerplate stuff there. And honestly, I might try that someday. I don't know. But for now, we're good. Anyways, wouldn't it be better? You're absolutely right. Seems that there's a point to have a semi-blank base project that you use for. Yeah, I should definitely like kind of start to invest into that, because oh my god, it's just too much boilerplate. I should try to do that for FFmpeg too, maybe. Do you guys would be like interested in such streams? I don't know. It's like making libraries for Zig. You can rotate freely. We're gonna try to vibe code most of it. But well, smooth interpolation. If you ever want to animate the camera, allow for perfect slurp. Yeah, slurp is good, but I wonder if we have that. Does Quad here have slurp? Yes, it does have slurp. Yeah, slurp is so good for animations. Anyways. Okay, let's try this. Whichever it's trying there. So first of all, we don't have from axis angle. In fact, let's try to... You're using what wrong? Here's the API. Well, it's not just the API, the whole code, but whichever. Okay, let's try it. Oh my god, what the heck did I do? Bruh, no. If I recall correctly, Vulkan is half writing code to run at least something, and another is linking it to project, because the big library devs apparently do not consider doing fast project setup at all. Yeah, it's just very hard to create like a little boilerplate abstraction thing for Vulkan and like satisfy everybody. But if I do it myself, I would assume that you want to use like the modern Vulkan extensions that you only have one window for simplicity. Although I did actually implement like multiple windows before, but it was such a pain. It's just too much stuff to keep track of. But what do you guys think? Like, what would be a library of that would help you with Vulkan boilerplate? But yeah. So as you can see right now, I give it the actual code. And here we go. Okay, the only problem right now that you can't really notice. Boom. Okay, that's sick. Oh, wait, what? Yeah, I'm so confused right now. Wait. And it also doesn't capture my mouse. Bro, where the heck is this? Okay, there we go. So yeah, it's inverted. It's inverted. The rotation mouse direction is inverted. And what else? Yeah, and the mouse should be released when the right button is released. And there we go. How about now? There we go. Okay, so now the direction is perfect, but the movement is not. Now the movement is inverted. What the heck? Well, at least in left and right. Yeah, in left and right it's inverted. The movement left and right inverted. Okay. So I just give it that quad like source code and I just let it do its thing. And okay, now it's working perfectly, I think. Right. Perfect. Perfection. Yeah, it's absolutely perfect. Wait, no, it's not. Kinda. I don't know. I mean, so right now I'm like moving the camera left and right, and it's doing this. Rotating the camera left and right. While rolled seems a bit warped. Yeah, all rotations in local space. I mean, that's what it's supposed to do from the get-go. He messed with the... It's inverted again. Bruh. Yeah, it's kind of inverted again. Nah, go back. Let me see what's going on here. Let's try to see what the heck is going on here. So I think the input is fine, right? So we got like the input there, the roll input, the move speed. I don't think anything wrong with that, right? So if it's captured, then if we got a window, why the heck it's trying to see if we have a window? Bruh, what? That sucks. Bruh, just say this. I'm not sure why over-engineered here. And in fact, yeah, that's fine, kinda. Yeah, this is window. And this is window, alright. So if captured, then we have a pitch, Q, quaternion from axis, and yaw Q. So we're rotating around the up vector. Okay. And here we're just like composing all the transformations there. So self the rotation, multiply, pitch Q. Wait. Okay. Is down. Yeah, I mean, it's fine for now, I guess. Let's just leave it as it is right now and move on. So we're good for now. Actually, we're not that good. It's like it's still what? Wait. Let's go back. Does this work? Yeah, adding the roll kind of sucked. What we gonna do? The right and left is inverted again. Can you decompose the math into descriptive functions like converting spaces, etc.? Okay, let's try this. Yeah, no, it sucks again. Yeah, I think the roll sucks. Bruh. You know, let's just grab the first solution. Refactored for the Z Algebra API. Yeah, just starting. It's wrong, just remove the roll, please. It's going back out of the quaternion. Okay, fine, whatever. As long as it works. Just want something working really quickly now. I could look into it off camera. Okay, so that's fine. That's kind of fine. Anyway, we're good for now. So what should we work on next? What do you think, guys? What should we work on next? Should we work on the skybox? So we don't need this anymore because we have a camera. Or should we work on a bit on the architecture? I'm gonna do, I guess, another poll. Why not? Start a poll. And either camera. Oh, well, actually we already did the camera. So skybox now. Skybox. Lighting. Or lighting is a big rabbit hole. So what else? I think that's all I have in mind for now. We could also work on post-processing, but there's no need actually. Yeah, that should be good to go, I guess, for now. Must contain between 1. Let's remove this. Okay, so the poll starts. Should we work on skybox or lighting? Okay, let's just end the poll now. See if there are any votes. There are no votes. So let's work on the skybox. Fine. Alright, so we gotta edit our texture to support 3D textures. So let's see how that would work. We're gonna do the refactor here. Can you refactor this to support 3D textures for skybox? Oh, what the volume textures, bro? No, I meant just probably a cube map. I think a cube map. How would we make a skybox using, what is it called? Yeah, using 3D texture instead of cube map. I think we probably want cube map. That's what I had in mind. Coordinate system. We will now use texture instead of simpler cube. I'm not sure what the heck it's talking about. 3D texture. I don't think this is what we want. Yeah, no way. I think it's volumetric skybox or something. The poll is dead. Yeah. So what do you think? Should we work on skybox or lighting? I've just gone with skybox. Yeah, I think it's probably just hallucinating maybe here, or some advanced. I mean, there is volumetric lighting, and I think that's the one for volume textures or 3D textures. So what we really want is probably just a six-sided. Yeah, probably that's what we want here. So let's just start a new chat. Actually, fine. Refactor this texture, or how would we implement a skybox, which is a cube map skybox? Okay, so it's going to be using layers, Vulkan layers. Okay, and cube compatible flag. I have never implemented the skybox in my life, so we'll see. I think maybe I did one day. I really do not remember. Implementing a cube map involves three main phases: loading the data, creating the specific Vulkan resource, updating your rendering pipeline. Your init function needs to be more flexible. Skybox. Cube map is essentially a 2D image array with 6 layers. So instead of having like 6 textures, I guess they're going to be using layers. Yeah. Array layers, 6 faces. Required for cube maps. Oh, what is that? Also do more commits and branches in. Oh yeah, I forgot. Thank you so much for reminding me. My God, that would have been a disaster. So this is working, right? Let's see. Bro, what? There we go. Okay. That was wild. Alright, so let's just... So we only implemented camera here, right? We only implemented camera. Yep, pretty much. So camera. Vibe coding required to do a lot of commits because LLM like to break things that were working a minute ago. Yeah, definitely. I just forgot. Cancel. Let's stage this and camera. Stage sync changes, and there we go. Okay, so I pushed the changes. Right now, let's see what's up here. Alright, so array layers. View all the 6 layers, and then you load the cube map faces. So we have a few decisions to make apparently here, because there's a lot of ways to implement this, I think. Sampler cube. Try Claude for this, maybe it's smarter. Claude, I think it's like the free version is very limited, I believe, no? Oh man, I'm not... Okay, let's see. So we're gonna give it the same prompt. And let's go. So there is Sonnet, Haiku, Opus. Limited in the size of files you could upload, but I mean it's fairly good. Okay, let's see. So it's the same prompt here. Yeah, it won't let me chat for long, and that's what's kind of suck. But, you know, we're trying it, fine. Okay, required 6. So it did the same thing as Gemini did, I guess, at least for this part. You used the array layers for Vulkan and create cube map from files. You give it like 6 path. And you go to the next free model. Yeah. Copy from buffer. So first of all, I want to understand like what are the options that we have. What are the options that we have in implementing a skybox? In implementing this, it seems you have used Vulkan array layers. I guess we could have also used what is it? Multiple textures or something else. I'm just curious. You're absolutely right. In graphics, there is rarely only one way to solve a problem. While Vulkan cube map arrays were showed previously in the industry standard for performance, this is what we discussed. A single vacay image with array layer 6 and the cube compatible bit. You sample in using a assembler cube and a 3D direction vector. Pros, hardware accelerated, seamless filtering across the edges of the cube faces, no visible seams. Only takes up one descriptor slot, requires all 6 faces to have identical dimensions and formats. So that's what array layer is for. It's basically a texture array, right? But it needs the same dimensions and formats. Instead of special cube map type, you treat the skybox like a standard 3D model, a box with 6 separate 2D textures applied to each face. Extremely simple, you don't need any special Vulkan flags or layer logic because the GPU filters each texture independently. You will often see a 1 pixel line at the corner where the texture meet. It also requires 6 descriptor bindings or a texture array. Oh, wait. What's the difference between texture array and array layers? Because honestly, I haven't really touched array layers that much, nor texture array stuff, so... This is very common in HDRI environments. Equirectangular projection, spherical map. Use one single 2D texture that looks like a flattened world map. You map the 3D view in direct spherical coordinates. I see, only one image to manage many high quality or distributed. I see, gotcha. So, This is the tables that I love. So you got the cube map native, you got 6 separate textures and equirectangular spherical. So the GPU complexity medium, layered setup, low, low, and shader logic simplest, standard UVs, and complex trigonometry functions. The visual quality best hardware, seamless, and here poor, visible seams, and good distortion at poles. Memory 6 faces, 1 large face. What should you choose? Stick with the native cube map option. It is the correct way to do it in Vulkan because it handles the edge filtering for you. Without it, likely spend hours trying to fix seams where the skybox faces meet. So what's the difference between texture array and array layers? Also, another question that I have. Goodbye, Sando Rals. Thank you for coming. Thank you so much. See ya. What's the difference between texture array and array layers? What other question I had? Does other APIs have layers in textures too? Okay, invoke a texture array are two sides of the same coin but describe different things depending on whether you're talking about the memory of the shader or the shader. Array layers, when you create a vector image, determines how many slices of image data stored within that single object. All layers share the same format, extent, width, height, and memory allocation. They sit back to back. You can create a wiki that looks just one layer or a view that looks all of them, like a cube map. This is exactly what you use for cube maps, 6 layers or stereoscopic VR, rendering 2 layers, 1 for each eye. Okay, texture arrays the shader axis. So a layered texture, you use sampler to the array. This is one descriptor that points to an image with multiple layers. In the shader, sample using 3D coordinates. UV layer index. Array of textures. Okay, this is a collection of entirely separate objects. Each one could potentially have different sizes of formats. Index them like a standard array. So array of textures and layered texture. Ah, I see. So array of textures is basically doesn't have to be uniform. They could be any format or any resolution. Yes, almost every modern graphics API uses the concept of layers through the terminology shifts slightly. Texture to the array in DirectX. Alright, fine. Depth or array layers, okay. Alright, let's try to use this code here. Add an init cube function and a create cube map from files. So we're gonna copy this part to our texture. Where is the texture? Let's see. Well, actually, let's do it here. Okay, so does it at least build right now? Yeah, it does seem like it's building. Great. What's next? Skybox vertex shader. The trick, reconstruct the view direction from NDC position, stripping translation from the view matrix. Frag directory. So this is skybox.vert. Oh, okay. And skybox.frag. Actually, I also had the idea of using slang, so we could take advantage of libraries there. But anyways, skybox.frag. So okay. Pipeline and order nodes. Key pipeline settings for the skybox pass. Do I have to like create another pipeline or what? Do I have to create another pipeline? Oh well, so I guess maybe we gotta like refactor the, like make the sky, like the pipeline into its own abstraction already, because this is getting out of hand already. Depth test on, depth right off, compare less or equal. So skybox texture, skybox sampler, pipeline layout, pipeline DSL, bruh. And push constants. I see. The depth buffer naturally handles the rest. Your scene geometry will write z less than 1 and include the skybox behind it. Okay, can you abstract pipeline first to its own file? Why it's doing this? Clean abstract that cover both your existing mesh pipeline and makes adding skybox pipeline trivial. Oh boy. Pipeline config. Then back in app.zig, create pipeline collapse 2. So you give it the verge text shader, the fragment shader, the color format, and the layout. That's pretty sick. And then we create the skybox pipeline, which can use the skybox shaders and the skybox layout. Yep, that's very interesting. Love that. Let's see if it works. So yeah, pipeline.zig. So far seems good. Now let's actually try to use it. So basically, so what does it cover? Wait. Well, where is the fields? Bro, what? Oh, it just like returns a vacate of pipeline. I see. It just takes a pipeline config, so it doesn't create like a new pipeline. Isn't it better to create a pipeline object with fields? So the layout, the descriptor set layout, the config. Yeah, I think that's way freaking better maybe. Now app becomes very clean. Replace the 3 separate fields, descriptor set layout, pipeline layout, and pipeline with just pipeline. Yeah, that's way better. Way better. Okay, so let's grab this. Let's paste it here and hope for the best. Destroy pipeline, pipeline layouts, pipeline set layout. Okay, that looks good. Now we're gonna come here and hopefully remove the pipeline layout and the pipeline and the descriptor set layout, all of these, and you're gonna convert it into one pipeline. Now obviously we're gonna say const pipeline is equal to import pipeline. Now usually would actually want to like share the, what is it called, like share the layouts and stuff, but right now let's just go with this if it's gonna simplify things for now, and then later on when we need more performance or something else, then we could see how we can refactor it. Pretty much. So yeah, all right, so now what we're gonna do here, so it's creating the descriptor set layout, right? yeah, it is creating pipeline layout, the descriptor site layout, and all that stuff. So all of this would go out of the window. PL, and how about wait, let's actually just grab this. Hold on. Now in app.zig, you just say this. So you give it the bindings like that. Okay, cool. But where's the sampler, for example? Sampler, we still need that, yeah. So we're just gonna remove this part, okay. So pipeline and just this part, it becomes this. So that's cool. Descriptor count 1 uniform buffer. And then here we pass in the sample. So we're gonna remove pipeline layout, descriptor set layout, and pipeline. And we're just gonna say pipeline is equal to pipeline. And then in the DNH, we're gonna say, instead of this and that, yep, just that. And next, what we're gonna do, can you zig build? And let's see what's changed now. So parameter type declared here. Oh, wait. Here we go. So self.pipeline.handle. And let's go. Zig build. And what we got, no field named, instruct app, obviously. Pipeline.dsl. Expected vacate pipeline layout, found descriptor set layout. Bro, what? Layout. There we go. Bro, I can't tell if it's working or not. Oh, there we go. So it actually works. Love that. Absolutely love that. So our pipeline works. Cool. Very cool. So as you can see right now, our pipeline is just this. It's really that simple. Very lovely. Now create skybox pipeline. So we're gonna grab this part to load the skybox shaders. Now obviously we gotta make sure to go to our compile shaders here and copy this part, paste it here, and instead of triangle we're gonna say skybox. Sick. Next up, we gotta add this skybox texture, the sampler, and the pipeline. So we're gonna add it here, for example. And then we're just gonna, okay, so we're gonna need to find some skybox apparently. But yeah. So we create a sampler, it's gotta be clamped to edges. Cleave maps should clamp, not repeat. And here you have one binding, combined image sampler. And it apparently uses push constants for some reason. To get a matrix 4 times 2. Huh. I'm not sure what that matrix is for. Probably, I don't know. Anyways, let's just copy this part and come to init function. And let's create the skybox stuff. And then let's add, yep, exactly, lovely. Next up, in the init, we're gonna destroy this stuff. Oh, well. After the device wait idle, and in record command buffer before the mesh draw. So we're gonna command bind the pipeline, whichever your camera exposes. So self.camera.view matrix. Okay. And sky push is okay. So apparently you give it the camera projection matrix and the sky view. CMD push constants. That's sick. And then CMD or command push the scripture set for the image. Okay, so let's grab this part and let's go to where we're drawing stuff. So here we got bind pipeline. So before that, we're gonna have this skybox stuff. Walaikum assalam wa Kieran, welcome back to the live stream. How's it going? So the camera, where is the view matrix here? A view matrix. We don't have a view matrix, so I guess we gotta calculate that. View model view matrix. Yeah, this is the projection. What it wants again? Wait, go back. Yeah, the view. Vulkan equal 3D engine? Yep. Okay, self.camera view matrix. Well, let's just give it this. So let's go back to the camera. Oh man, I'm getting lost. Oh, okay, we're already in the camera. My bad. So, and we're basically gonna like have the view matrix alone, the projection matrix alone, and then finally the descriptor matrix. So that's cool. Next up, then in app.zig, the skybox push constants become get the view matrix, and then sky push. A lot of camera methods. My brain goes, yeah, it's insane. Sky push here. Okay, did I miss anything? Did I actually compile the shaders already or no? And let's just make sure that we're using this exact shaders, just in case. And now let's compile the shaders. Whoops. And do we have them now? Yeah, perfect. And yeah, I think let's try now. Would this work? No clue. Oh, we don't have the skybox images yet already. Expected type VK buffer image copy found. What do you mean? So it needs to be constant? That's strange. Why do you care? Expected type. Oh no. It's expecting. So we could probably PTR cast that, right? Yeah, we could probably PTR cast that though. Wait. Oh yeah. Let's try to PTR cast that. Alright, LLVM image object. Boom. Bro, remove the validation layers for now. I just want to see if there's any error. Yeah, obviously it cannot load them because there is no cube map textures yet. Where can I get some cube map textures for testing? Best quality, download as HDR or go to a converter site to get 6-face PNG. Slightly more work, but worth it. Okay, let's try this guy. Hummus, I think. It's probably Arabic. Hummus. I'm not sure. I don't know. Anyway, so we have these skyboxes. I mean, I guess whichever floats your boat. There's nothing like neutral, like just a regular skybox. All of them are weird. What do we guys, which one should we go for? Oh man, I can't choose. Bruh. Let's go for this. I don't know. Save. Whichever. We just want to test this. Okay. And now how are we gonna... And there we go. That's sick. So I'm just gonna grab this to here and like have it in here, I guess. And yeah, this is like the skybox. Skybox. So let's see the path that they're using here. Where app.zig. Okay. No, actually I think in the... My god. Create from file. Copy from buffers. Init cube map. Where is the path? There we go. Init cube map from files. There we go. So texture slash skybox slash. But this is being done, I think. Your chat panel doesn't refresh. Are you sure it's working? So I think it does this at runtime, right? Yeah, it does that at runtime. Yeah, it's loading PNG. Interesting. So we're gonna do textures. So we could just like have, I guess, maybe here a folder called textures, and then have the skybox in it. Move. And readme. Is licensed under Creative Commons attribution. So I'm thinking what I'm gonna do with this. Let's go back to app.zig. So it needs negx. So here it uses pxnxpy. Okay, let's go back here. What's the standard naming for the PNG faces? Because I have... we're gonna do ls textures slash skybox, and we're gonna wl copy. Oh, what? So why didn't you copy that? What the heck? Alright, fine, let me just copy it myself. What's the standard? Is there like a standard naming? Oh my god, I can't type it. What? Something strange going on here. Okay, sure. Let's just grab this. Now let's try zig build run. Yeah, it failed again. So I guess we gotta make sure maybe to have this copied into the binary path. Or maybe we could run it from here. How about that? So we're gonna say zig ouch bin kodotaku zig vacay. Nah, that doesn't work either. Well, that's strange. Textures, skybox. I'm not sure what SDL path it's kind of looking for here. Load PNG, what paths it is like expecting, I mean working directory. Huh. So I guess maybe that's what we're missing. Alright, so where's the run? The run. Run step, I guess? .cwd. Nope. So run command. There you go. And I guess just wait. What it expects again? A lazy path. So b.path. And we're gonna give it this. Too simply. Yeah, I think that's basically it. Now let's try to zig build run. And we're still having some weird problem here. Alright. Well, you know what I'm gonna do here is, before returning error to SDL, I'm gonna make sure that I'm logging the error just to make sure that it is the error that I'm expecting. So like log error. Whoops, what? There you go. And we're gonna say c.sdl get error SDL. S string. Oh, what? Error SDL, and it says nothing. That's very strange. Oh, there we go. What the? File is not a PNG file. What? Oh yeah, it's JPG. Okay, so as you can see, the path wasn't the problem. It was the fact that it's JPG, bro. Oh man. So we gotta figure out a way. I don't think SDL have JPG natively. So this sucks. We could like make some sort of command to convert those into PNG, I guess. Yeah, probably that's what I'm gonna do to keep this very simple. Fine. So let's see where we're creating the box. So instead of JPG, can you just make it PNG? Whoops. JPG. What? Man. JPG. Replace with PNG, please. PNG, PNG, PNG. And there we go. Now, what we're gonna do, we're gonna see some way. All right. Let's go to ChatGPT really quick. Make a command that would convert all images in the current directory in Linux. Oh, well, to PNG from JPG to PNG. Come on. Image magic. I wonder if I have it. Arch Linux. Come on. I don't think I have image magic here. So let's install it really. Net upgrades. Oh, I already have it apparently. Okay, fine. Can we just copy this? And what it's doing? Yeah, let's just go to textures, skybox, and let's just run this command. Hopefully, no, it's official. My God, I hate this. So let's have a new file, new script, I guess. And mail. All right, convert images. Convert images, and we're gonna do shebang /bin /bash, or yeah, bash, and let's just paste that stuff in there. Can you make it take a path instead to the directory? Add shebang to. There we go. And here we created a little tool. Sick. Now chmod +x convert images. Oh. And let's try convert images. Okay, and let's give it the directory, which is in our case texture /skybox. And there we go. Sick. That's what I'm talking about. Man, nice. Love that. All right, so let's try now. Zig build run. Would we have a skybox or no? Bro. Bro. What the heck is this? That's insane. So we did it. This This is my first time probably implementing a skybox in Vulkan. Totally vibe coded. Well, not totally, but mostly, I guess. Tilt. There is a tilt that I was trying to implement a tilt, but I had a problem, so I just kind of like ignored it for now. Maybe because I have to look into the math, and I don't want to do that in the stream. You know, I'm gonna spend like hours here trying to understand what the math is doing there. So I'm gonna do it off screen and maybe come up with the solution, then maybe even like explain to you what's going on there, because it was just like vibe coded mostly. But yeah. All right, so that's the skybox. Insane. So what do you guys should we do next? What do you think should we do next? That's pretty sick. I really didn't know it would actually work, cause what? That was so cool. Next rotary table. What's that? Cam movement. Rotary. I already done the rotating camera, and right now we have like a controlling camera, so you basically just move it yourself. You just right click, hold right click, and you go. So yeah, that's quite sick. I mean, how much we've been streaming for? Like 2 hours. Yeah, I guess maybe we'll just stop the stream here. But we have some validation errors apparently, so that's interesting. And apparently it's because of, you know, I'm not really in the mood to read all of this. So let's see. It's probably like image layout transitions. So let's see. Okay. So we only transition one layer. Fix copy buffer to do its own barrier covering all 6 layers instead of calling self.transition layout. But wait, it's hard coding 6 layers, bro. I mean, that's fine. That's fine, I guess. That's fine. So let's just grab this and copy from buffer key. While you're at it, you might also want to add the layer count parameter transition layer itself, so it's reusable for both cases. Alright, fine. So let's go ahead and to app.zig, I think, or where is it? Texture. Yeah, where's the texture? Texture.zig. And the transition layout. My god, there's a lot going on here. And let's see. So as you can see, currently we're hard coding layer count 1. But I do believe maybe there was like a way to select all layers. Sentinel to select all layers. There we go. That's what I'm talking about. I just faintly remembered there was such a thing, so yeah. Vacay, actually, vacay. There we go. Sick. Sick. So I guess that would work just fine now. It does take some time to actually load up, because like we're loading 6 images. And now we don't have any validation errors anymore. So that's cool. That's pretty cool. Yeah, it takes a long time to load the skybox. Man. So maybe we should look into like asynchronous loading next using SDL3. Like loading the texture asynchronously, but yeah. Alright, so I think I'm just gonna stop the stream here. I think it's enough for today. Alright, so there was a lot of stuff going on here. So obviously we added the textures, and we added the new shader skybox. We have made a pipeline abstraction which was totally vibe coded. It just like got refactored, using what is it called again? Using Claude, right? And we have this build.zig. We just added this CWD, though I wonder if it really necessary though. I mean, let me see, because it could be maybe not the issue here. So if we revert selection there and we try again, yeah, I think it works without it. Yeah, it works without it, so we're fine there. And is there anything else here that we need to? No, I don't think so. Could just discard the changes in build.zig. Try, make sure that it's working. And convert images, compile shaders. We added some shaders there. And yeah, we're good. App.zig. So yeah, that's pretty sick. Love that. I didn't know like Skybox had all this work going on, so, but it's interesting that it's working. Alright, so I guess that's it guys for this stream. I'm just gonna like commit this into GitHub and we should be good to go. So Skybox, commit and sync. And yeah, that was it guys for this stream. Thank you all for watching and see you in the next one. Goodbye everyone.